Day two of triangle congruence. These first two here from day one, a little review. SSS and SAS. Remember, there's 6 parts to a triangle, 3 sides and 3 angles. To show the two triangles are identical or congruent to each other, you only need 3 of those 6 parts. But you have to have a specific 3, like all 3 sides. That works. So SSS, if you know that side's congruent to that one, and so on and so forth. All 3 corresponding sides are congruent. That's enough to say the triangles are congruent, and therefore all the corresponding angles are congruent too. You don't have to worry about proving that those are congruent, the angles. You just know that they are because the sides are. You only need 3 out of the 6, and as soon as you get those 3, you automatically have the other 3. All right, but it doesn't have to be all 3 sides. It could be 2 sides and an angle as long as it's a specific angle. 2 sides and an angle only works if that angle is in between the 2 sides, meaning that angle is what those 2 sides make. These 2 sides make that angle. These 2 sides do not make this angle. This side has nothing to do with this angle. These 2 sides do not make this angle. This side has nothing to do with that angle. These 2 sides make this angle. If you're not sure, you can cover up the third side that you're not using. And then you can see these 2 sides are used to make that angle. That's the angle you need. In between the 2 sides, the A is in between the 2 sides. All right, now for the other 2 that use 3 parts, the other 2 are going to have 2 angles in one side. So we went from no angles, 1 angle, and now both of these we're going to have 2 angles. And this one's a little bit easier because it could be any 2 angles in a side and it's going to work. You just need to know, is it called AAS or is it called ASA? I'm actually going to switch those orders. I think it's a little easier to explain ASA first. So ASA or AAS. All right, as long as you have 2 angles and a side, you've got congruent triangles. You just need to know, is it AAS or is it ASA? So here's the difference. Just like SAS had A in the middle, ASA has S in the middle. So you need 2 angles with a side in between those 2 angles. So say the 2 angles are these 2 right here. Those 2 angles we know are congruent. So there's 2 parts. We just need a side now. We can pick any side and it's going to work. But it has to be only one specific side to be called ASA. It has to be the side that's in between the 2 angles because the S is in between the 2A. And out of the 3 sides, the one that's in between those 2 given angles is this one. You got an angle on each side of it. That side is in between those 2 angles. If I would have picked, let's say I picked the same 2 angles. Let's say I would have said this side is congruent to that side. I still have congruent triangles, but if I said this was ASA, I would be wrong because this side is not in between those 2 angles. Like I said here, the only side that's in between those 2 angles is this side. That's ASA. If I would have picked either one of these sides, now I have a side that's not in between the 2 angles, and it's AAS. So I could have picked the bottom ones, or I could have picked the left-hand side. It doesn't matter. If I pick this side over here, say that side's congruent to that side, that's still AAS. You still have 2 angles and a side that's not in between those 2 angles. So if you have 2 angles, let me re-stress this. If you're given 2 angles and one side, they're congruent every single time. The answer is yes, they're congruent. You just have to decide which one of these 2 is it. And the way you do that is you look, what side did they give you? If they gave you the one side that's in between the 2 angles, then it's ASA. If they gave you one of the sides that's not, it's AAS. So there's your 4 main ways to prove that triangles are congruent to each other. No angles, just all 3 sides. 1 angle only works if that angle is in between the 2 sides. 2 angles in a side always works. You just got to decide which one it is. Is the side in between them or not? All right, so let me give you an example problem here. Let's say you have this. And we'll call this triangle 1 and triangle 2. And I'll say that this is a right angle and that side is congruent to this side. Would that be enough information to say that those two triangles are congruent? Well, at first glance, my answer would be no, because we need 3 parts and we only have 2. We have an angle and we have a side. Really, we only have 1 angle. We need a corresponding angle over here, but we have that because this is a tricky angle. That's a 90-degree angle. And remember, this is a linear pair. This is a straight line. So these 2 angles right here, that's 180 degrees. Well, if that much of it's 90, the other part must be 90 as well. So those are both congruent angles. Those are both right angles. So that's an angle and a side is what we have. So we have an angle and a side. We need a third part here. Well, the only third part that we have is a shared side. And the easiest way to recognize this, when you have triangles that are touching or overlapping, I recommend redrawing them, separating them and redrawing them. So if we separate these and redraw them, you have something that looks like this: triangle 1 on the left and triangle 2 on the right. Now we knew that side was congruent and those are both right angles. So can we get one more part? Well, yeah, this side right here, because that side is the same side. We use the same length right here for both those sides. So those have to be equal to each other because it's the same line. It's this line right here. That's a shared side. So now we've got our 3 parts, 2 sides and an angle. But 2 sides and an angle doesn't always work. If we have 2 sides and an angle, that doesn't work. But if we have 2 sides and an angle in between them, that works. This is always a no. That's not enough to prove it. This is always a yes. So which one do we have? Well, you got to check. Is the angle that we have made up from the 2 sides that we have? Yes, this angle is made up of these 2 sides, and that's what we have, are those 2 sides. So we do have side, angle, side. So that's a yes. So let me give you one more, since that was kind of a review from yesterday's problems. Here's one that'll either be, I'll give you 2 angles in this one. Let's say we have a parallelogram. Well, it looks like a parallelogram with a diagonal. Let's say we have this is congruent to that, and this one's congruent to that one. All right, so there's 2 angles. Remember today's lesson, as long as you have 2 angles, it's going to work if you can get one side. If you have 2 angles, you only need one more side and you're good. So let's separate these 2 because they're connecting. So it'll look like this. And we had this angle was congruent to that one. So these triangles are basically rotated. You'd have to rotate this triangle to get them to match up exactly. So can we say that any of these sides are the same? Yes, it's the same strategy as that last example, which is we shared a side. This side right here is the same side. It's the diagonal of our parallelogram. It's this side. This side is being used in both triangles. It's right here and it's right there. So anything's equal to itself. So these sides must be equal to each other. So now we have 2 angles and a side. That means we have congruent triangles. We just need to know, is it angle, angle, side, or is it angle, side, angle? Where is that side? Is that side in between our 2 angles, or is it not in between the 2 angles? It's in between the 2 angles. This is the side that's in between those 2 angles. If we would have had something that looked like this, that's 2 angles and a side. That's congruent, but that side is not in between the 2 angles. So that would be AAS. But we didn't have AAS. We had the side in between them. We had ASA. So that's congruent for ASA. So that's what the problems are like today. Now, they don't specifically ask you how would you get these 2 triangles to match up, but you need to know how you would do that for the test. And that just means, would you reflect them or would you rotate them? So what do you think? Would you flip this over to make it match, or would you spin it? You would have to spin it. So this is ASA, and to get them to match, you would have to rotate it. But we already talked a lot about rotations, reflections, and translations. Hopefully you've got that down pretty good. You could see that this would have to spin and not flip.